All right. So number 5 and 6. So what we did in the last couple examples is important to understand the trig ratios and kind of where they come from and how to set them up and which one's which. But really, what one of the vital and applicable skills that we'll use with trigonometry is finding missing parts of triangles, right? And the reason that's valuable is because in any geometric or in any polygon at least, or any kind of you know really even with circular things, even you can find triangles in those, but there's basically triangles in every shape, right? Especially in polygons, you can divide any polygon up into a bunch of triangles. And so if you can find a missing part of a triangle, you can find really a missing part of any shape, right? Rectangles, squares, any polygons, and things like that. Okay, and so that's the usefulness of trigonometry. So here we have a right triangle, and we're given the angle theta this time is 22 degrees, the reference angle, and then we're given one side and we're asked to find another, right? So far with trig or with geometry, if we're given one side of a right triangle, we don't have enough information to find the other, right? We need two sides with Pythagorean theorem to find a third. And so with trigonometry, all we need is one side and an angle of a right triangle. We can find any other side. Okay, and we can actually find everything about that triangle if we wanted to. We could also find this. We could also find this other angle just by subtracting from 90, right? Subtracting 22 from 90. So anyway, so that's the nice thing about trig is if we're given a side and an angle and a right triangle, we can find everything else about that triangle. All right, so let's set this up. So first of all, this is our reference angle, right? The given angle is our reference angle, and so that means that this is going to be opposite, and then this is going to be adjacent, right? And so that's what you want to do is try to figure out which two sides matter, quote unquote, right? Which two sides matter. So the sides that matter are the one you're looking for, which happens to be opposite, and the one you're trying to find, or excuse me, and the one the one that's given, which in this case happens to be adjacent, right? So if you're given two sides, just pick one, right? If you're given two sides to find the other, you can use Pythagorean theorem for that matter, but generally you're going to be given one side that matters. In this case, it's adjacent, and then you're going to be trying to find another side, and that's the other one that matters, which in this case is opposite. So the two sides that matter are opposite and adjacent. So we want to look back and see which trig function deals with opposite and adjacent. Okay, and so we can look at our handy dandy. Not that one. We can look at our handy dandy reference here that we have, and we can see that there's two, right? There's two trig functions that deal with opposite and adjacent, tangent and cotangent. So we can use either one. But if you look on your calculator, you have three trig buttons, right? And the three trig buttons are sine, cosine, tangent. So you still can do these on your calculator by doing 1 over sine for cosecant, 1 over cosine for secant, and 1 over tangent for cotangent. But it's a lot easier just to use these three, okay? So that's what we're going to be picking from is these three when we're trying to solve for a missing part, okay? So this one, tangent matches up, like we said, because we're talking about opposite and adjacent, right? So what I'm going to do is I'm going to set up tangent. So I'm going to say tangent of 22 degrees, so that's the reference angle, right, equals opposite, which is x, over adjacent, which is 10. So that's our setup, right? So tangent is the opposite over adjacent, so opposite over adjacent, right? And then now I'm just going to solve for x. So I just want to get x by itself. So I'm going to multiply by 10 on both sides. These cancel out. And so I get x equals 10 times tangent of 22. Okay. All right. And so that's really it. That's all we have to do to solve. Now we can just plug this right into our calculator. So you're going to plug it in just like it looks, 10, 10, 22. Now, one thing I want you to do is before you calculate this, you're going to go on your calculator and you're going to push mode, And then make sure that you'll see a place where there's degrees and radians. And so make sure that degrees is highlighted, okay? And we'll talk about radians later on, but for right now, make sure degrees is highlighted. So, so scroll down and then select degree and push enter and make sure that that ends up being highlighted rather than radian. The default for your calculator is radian, so that's why I want you to double check that. All right, and then once you have it set in degrees, you can do 10, 10, 22 and push enter, and that should give you the answer. So we get x is approximately, and it says round to the nearest tenth, right? So it's 4.04, so it'll just be approximately 4.0, okay? And we don't have any units here. We could, right? This could be, they could have given us feet or, you know, miles or inches or some type of unit, but in this case they didn't, so we'll just leave it without. All right, now number 6, trying to find x here. So let's catch our bearings, okay? So we have this angle here, 60, right? And that's our reference angle. And so here is the right angle, so that means this is hypotenuse. So hypotenuse is one of the sides that matters because that's where x is. And then the other side that matters is the 5, which is going to be adjacent because it's next to the reference angle, right? And so this would be adjacent. Okay, so hypotenuse is an adjacent. So of our 3 main trig functions here, which one deals with hypotenuse and adjacent? The answer is cosine, right? So I'm going to set up cosine. So I'm going to say cosine theta equals, and then it's adjacent over hypotenuse. So it's going to be 5 over x, right? Adjacent over hypotenuse. Okay, so now I want to solve for x. So you can do this a couple different ways. Like one way is to multiply by x on both sides and then go from there. You can also cross multiply and put a 1 underneath cosine. Get the same idea, basically, same result. So this will be x cosine theta equals 5. And one thing I forgot about that I failed to do is that we do have an actual value for our reference angle, right? So our reference angle is 60. So I want to put 60 in here. Sorry about that. All right, so cosine 60 equals 5 over x. We multiply both sides by x. Then we're going to divide both sides by cosine 60. And we get x equals 5 over cosine 60. Okay, so now that we have it set in degree mode, we can just plug that right in. We don't have to check anymore for degree mode. So it'll be 5 divided by sine cosine 60, and then push enter, and that'll give you your answer. And what you'll get is 10. Okay, 5 divided by cosine 60 turns out to be 10. So that's the answer for number 6. And I want to point out too that this is a 30, 60, 90 triangle, right? Because this is 90, 60, so this would be 30. So you could also use your 30, 60, 90 skills if you remember them to find missing parts. So it works both ways with 30, 60, 90s. But the nice thing about trig is you can do it with not only 30, 60, 90s, but you can do it with any right triangles, right? As long as you know one angle, one acute angle in the right triangle and a side, you can find anything else.